So we talked about average rate of change. The constant rate of change was the linear, right? And any 2 points I pick, I've got the exact same slope as long as I do it correctly. When I have something that is not linear, if I pick a different set of points, then I'm going to get something different, right? And we have the 2 points that we're finding the slope between, and that gives us a secant line. Yes, secant line. If it intersects at just 1 point, what's it called? Tangent line. Okay, so here's a little side note about tangent lines. If I have a function, let's just say we have a cubic function, looks something like that, right? And I have a point here that I want to find the instantaneous rate of change. Right now we're doing average rate of change, but remember the tangent line gives you instantaneous rate of change. So I could find the slope of the line that's tangent to the function at that point, all right? And that would give me that instantaneous rate of change. A tangent line intersects at exactly 1 point, right? It's what we learn in geometry. We learn it with circles, okay? But if you look at this, do we all agree with tangent right here? When this line continues, what's going to happen? It's going to intersect it again, right? So you have to be careful with the idea of all tangent lines intersect at exactly 1 point, because that's not really the best way to say it, and it's hard to give it a true definition without the calculus behind it, but here's what it boils down to. And because it's something that Mr. Ackerman and I have talked about it, is he said, you know, how exactly do y'all talk about this in geometry? And that's really the only thing you ever talk about in geometry is with circles. I mean, I do say you will do it with other things, but we never really do that. Well, with circles, it's exactly 1 point no matter what and whatever is going to happen. But with functions, it could be exactly 1 point, or it could be that it's going to intersect at exactly 1 point here, but then it's going to keep going. So I could use this as a secant line, and I could find the average rate of change between these 2 points for whatever reason I might need that. Or when we talk about it being tangent, all we're really concerned with is it tangent right here in its little space right here, like between some sort of interval. So in that interval, it's tangent to that function at that point. Does that make sense? Just right there, right among, because I could take these 2 points, and if I slide them closer and closer and closer together, they can be really close together and it still be a secant line. But then once they actually come together, then that's going to make it a tangent line because there's only 1 point. Okay, so I wanted to kind of make a clarifier on that exactly 1 point type of thing. It's when you get to it functionally, then it's exactly 1 point in that interval that you're talking about, or whatever it is. Okay. And again, we will talk about those, and that comes like at the very end of the year. We kind of bring this average rate of change back, but I wanted to kind of at least make those connections now. Okay. So then we did that. That was really no big deal. It's still slope, right? Just talking about it a little bit differently. And then I don't know if we skipped 9 in here or not, but we did skip it in another class because I was trying not to go too fast, but also get to a certain point, and I still never made it. I don't know what I did in second period because I got a lot farther with them, but we're going to start with 12. Okay. I didn't do any of these with anybody yesterday, but I do want to do these with you today. Again, this is more, I think you get the slope aspect of it. I think you get the concept, but I still want to work through some of these because computationally, some different things happen that I want to make sure we're understanding and not doing weird stuff with. So let's start with, we'll do f of negative 2 together. So f of negative 2 equals negative 2 to the 4th plus 3 times negative 2 squared minus 17. Because honestly, this is like pre-algebra stuff. It's just order of operations figuring this out, right? So I know that this to the 4th power will be positive, and then I saw this negative out here, so it's negative something. 2 times 2 is 4, times 2 is 8, times 2 is what? 16, okay? Plus negative 2 squared times 3 would be what? 12, and then minus 17. So negative 16 and 12 will give me negative 4, and then with a negative 17 gives me negative 21, and that is f of negative 2, right? Hopefully there's no big struggle with that. Are we likely to possibly mess up on something like that? Well, yes, because we're human. You just have to watch your sign errors and, you know, weird things happen. But I don't think if you missed that, it would be because you completely didn't understand. I think it would just be one of those brain farts. All right, so now we're going to do f of 5. That's going to be negative, and then 5 to the 4th plus 3 times 5 squared minus 17. And then I want you to come up with, on your own without talking to anybody, what 5 to the 4th power is. Okay? However you would do it. Not how your neighbor would do it, just whatever. There's not necessarily a wrong way unless you get the wrong answer. But 5 to the 4th, figure out what that number actually is. And we're going to talk about the different ways we could go about that. Okay? Okay, but just your own, not your neighbor. It's okay if it's the same. It's okay if it's different. Again, as long as you get the right answer, your way is probably not wrong. It's just different. All right, so what is the number? 625. Okay, so I want somebody to tell me how they came about getting it. What'd you do? Okay, so is 5 to the 3rd power something you just know, or is it just something you can calculate quickly? Okay, so 5 to the 3rd power, and then you multiply that by 5, right? All right, so that works. Would y'all agree with that? Kind of splitting it up just a little bit into either something you know or something that's maybe a little bit easier for you to calculate. And especially with this, what is 5 to the 3rd power? 125. So if I need to take 125 times 5, I mean, thinking in terms of money is great there. You got $1.25, you multiply by 5, and you can split it up that way, or you can, some people actually still wrote it out, or you just know it and do it in your head. Again, everybody thinks different ways, so that's good. That's one way. What's another way? What'd you do? Okay, good. So she basically just did every single one, like if we wrote it out and did all that, which in the end ended up almost exactly what he was doing, right? She ended up multiplying the same numbers in the end. So again, they're different, but kind of the same. So that works. All right, what else? Anything else? Anybody do anything different? Everybody, what'd you do? Okay, and then, so you got 25 times 25, and then you should know what that is, right? That's good, and that works too. And that's what I wanted to show you. Like, you doing it 5 times 5 times, there's nothing wrong with that. If it's a different number, then you might not want to, do it that way. But when you look at that, and it's 5 times 5 times 5 times 5. I mean, I doubt any of you wrote it out like that, and that's fine. I just wanted it there when I talk through it. So I can do, this is 25, and then times 5, I get 125, and then times 5, I get 625. Again, absolutely nothing wrong with that. But I do know that this is 25, and this is 25. Even if in your mind you didn't think, I'm going to split it into 25 squared and 25 squared. That's what I did, and that's what she said and probably was thinking. But even if we weren't thinking it that way, you can still do it. And then you should know your perfect squares up to 25, so that should be something that doesn't really take you that long. And again, it's not about being the fastest at it. It's about not having to do all the scratch work all the time, because that's where the careless mistakes come in. Okay, good job. So it's 625, however you found it. Plus 5 squared is 25 times 3 is 75 minus 17. Okay, so I'm going to combine these two first, and I know that it's going to be negative because that one's a much bigger number, so I'm going to go ahead and put my negative. And I'm going to have to subtract them then. So I got $625, or $6.25, and I give you 75 cents. How much money do I have left? $5.50, okay? So $5.50, I don't have to really think of subtraction much, minus 17, and that means that f of 5 equals negative 567. Okay, everybody okay with that? My 550 kind of looks like 560. It's 550. That is a 5. My handwriting's just really bad. Okay. All right. So then I have to do the secant line. Slope of the secant line. That's f of 5 minus f of negative 2 over 5 minus a negative 2. So I found all this stuff. This is negative 567 minus a negative 21 over 7. So what's negative 567 minus a negative 21? Negative 546 over 7. So either that's my answer or it divides evenly, one of the two. How many times does 7 go into 54? 7 times. With 5 left over, so that gives me 56. 7 goes into 56 8 times, and that is the slope of my secant line. Everybody okay with that? All right. We all get the concept, right? Right now I'm just focusing on numbers. I think we get the concept. I just want to. All right. So we're just going to do the next two together just to push through them because they're not crazy hard, but again, just things I want to make sure we're all on the same page with. F of 8. I don't know why I decided to do the second one first here, but I did. It doesn't really matter. So F of 8 is 8 minus 4 over 8. So 8 minus 4 is 4 over 8, which gives you 1/2. And that's equal to F of 8. Then I find F of 2. That's going to be 2 minus 4 over 2, which gives me negative 2 over 2, which is negative 1. And that is F of 2. Then I find the slope of the secant line. So that's going to be F of 8 minus F of 2 over 8 minus 2. That gives me 1/2 minus a negative 1 over 6. So 1/2 minus a negative 1. What is that? Okay, so what do I write down? 3/2. I would never in a million trillion years ever write down a mixed number. The first thing you might think is 1.5, because I mean that it is 1.5, but that is not what you put in ever, okay? Because that's just going to make things weird and wrong. But it's 1.5, which as an improper fraction is 3/2. Again, don't even think about writing down 1.5 or I will kick you out of my classroom. All right, so this is 3/2 over 6. Then you got to know what to do with that correctly, okay? And there is something like a step you can just do and not have to write down what I'm about to do. But if I just do that here, some of you are going to think there's like magic happening, and there's not. And I want to make sure you understand the mathematical reason why it happens. So dividing by something is the same as multiplying by what? It's reciprocal. So if I divide by 2, it's the same as multiplying by 1/2. We all agree with that? So here, this is saying 3/2 divided by 6. So that's the same thing as 3/2 times 1/6, right? Again, I'm not saying you would necessarily have to write this step. Some of you might want to because it's the only way it makes sense to you. That's fine. But at this point, I can just like multiply the 2 and the 6 in the denominator. But again, if I did that, y'all are going to try and like do that with other things where it doesn't work. So this is why I'm doing it. And then I can reduce. 3 goes into 3 once, goes into 6 twice, and I get what? 1/4. And that is the slope of the secant line. And if I just blew your mind with fractions, you best go live on Khan Academy this weekend. You got a long weekend. You go figure out your 4th grade math, okay? Because this cannot be stumping you. It just can't, okay? If you struggle with them, okay, you've got to get past it. It is what it is, and that's where you are in your math life, but fix it, okay? All right, any questions? Awesome. All right, so then this one. We're going to do f of negative 1 equals the square root of negative 1 plus 5. That gives me the square root of 4, which is what? 2. Is it plus or minus? No, not unless you introduce the square root. All right, so that is my f of negative 1. Then I have to find f of 7. It's the square root of 7 plus 5, which is the square root of 12. Is that a perfect square? No. Do I reach for my calculator? No, not unless you want me to slap your hand. Then you got to simplify it. What does that simplify to? 2 square root of 3. Good. 2 square root of 3, and that is f of 7. Okay, we good? So if you're not familiar with simplifying square roots quickly, because I feel like if you have not been in pre-AP math, or at least in this district or on this campus, and then now you are, you're going to be fine, okay? But you may not have been required to simplify square roots a lot and been required to do fractions a lot. And so those are things that you can and you are capable of sharpening your skills on. You just might need to go spend a little bit of time on your own with it, and you'll get there. It's not that big of a deal. It's not nearly as bad as you think. Just ask everybody else that can do it quickly now that they thought they were going to die early on, but now it makes sense and it's no big deal. All right, so now that we've got all this, we've got the slope of the secant line. And that's f of 7 minus f of negative 1 over 7 minus a negative 1. So that gives me 2 square root of 3 minus 2 over 8. Can I subtract these? This 2 square root of 3 minus 2 becomes the square root of 3? No. Can I just reduce the 2 and the 8? No. Okay, but what can I do to the numerator so I can reduce this? Factor. So I'm going to factor out of GCF, which is 2. And I get square root of 3 minus 1 over 8. Now can I reduce it? Yes, I can. So 2 goes into 2 once, goes into 8 4 times. So I get the square root of 3 minus 1 over 4. And that is the slope of my secant line. And I don't know if I pointed this out yesterday or not. I think the instructions at the top say round to the nearest whatever. No, just mark that out. Mark that out on your homework too. I don't want you putting this in the calculator. You absolutely positively have to have the skills to simplify this and handle this stuff. If you don't have these skills, you're not going to make it. Okay, and the calculators that you're going to be allowed to use aren't going to do this for you. Okay, we good? You good? You don't look good. I mean, you look good. You look really nice today in your little 70s, but that look on your face kind of breaks my heart, so I don't know. You a little freaked out right now? Don't be. It's okay. It's okay. If you're a little freaked out, that doesn't mean you need to run screaming. That means you need to get on Khan Academy, and you need to, what's freaking you out? The square roots? The whole thing. So it's probably because of the square roots? Okay. So you need to get on simplifying radicals. I can get some stuff. I mean, and who else is like freaking out over the radicals right now? Be honest. Okay. So were you in pre-AP math last year? Okay, and that's why, okay? And that's one reason why it's harder to jump in on the track a little bit later. Not impossible. I'm not saying you don't belong in here. That's not what I'm saying at all. But it's harder because along the way that rigor hasn't been there for you, and you've been allowed to use the calculator. They haven't put some of these questions on there because it maybe wasn't necessary, but it is if you need to get through pre-calculus, regardless of whether it's pre-AP or not, and then to get through calculus, this stuff has to be okay for you. At some point, you should have learned to simplify square roots. You may not have had to do it much after that. You know, they may not have kept sticking it in your stuff, but you had to at least learn it. So at least if it's there and it was learned at some point, you strengthening those skills is not that big of a deal. And maybe that's something that I will pull all of y'all in a priority math time, and we'll talk through it, and I will help you kind of feel better about that. So you have to be real honest with me about what's freaking you out and what you feel like you're missing. That way I know what to do with you to get you to that point, okay? Because I will help you with that stuff, but I got to know what it is. You can't just be silent and be silently freaking out and not know anything, okay? We good? Almost good? You'll be good. We'll be good. We'll put it that way. All right, let's look at 16. Because there's certain things like this. You all learned this in Algebra 2, and I don't want to hear your sob stories about not knowing how to find the max, because give me a break. Okay, but that was done no matter what level of Algebra 2 you were in, right? You might have done harder problems or whatever, but that, everybody found the max. We all did that. We got at least this far yesterday. I think this is where we got and we stopped. Is that correct? Okay. So now what we were doing, let's go back. A ball is thrown straight upward, blah, blah, blah. It's given this where t is time in seconds. Find the average rate of change in the height of the ball from when it reaches its maximum height. So from when it reaches its maximum height to when it reaches the ground. So we found the maximum. We got to find when it reaches the ground, right? What the time is. We know when the time starts, it's on the ground, and that's 0, but that doesn't really help me right here. So how do I find the time when it hits the ground? Tell me about where's the ball when it hits the ground? Yeah, it's 0. It's on the ground, right? So what's its height? 0, because it's on the ground, yes? All right, so this represents the height, yes? So I know right now the height is 0. It's equal to negative 16t squared plus 80t. There are 2 times when it's on the ground, when it starts and when it ends, right? So I've got this. I got to figure out those times. What do I do here? I got to solve it. By doing what? Factoring, okay? So, I mean, I could use a quadratic formula, but I don't know why in the heck you choose to do that right here, so no. But, yeah, by factoring. So, can I factor out a GCF? Yes, I can factor out a negative 16t. What does that leave me with? T plus, minus, not plus. Minus 5, because you factored a negative 16. And now this won't change. Okay. Minus 5. All right, so now it's factored. Boom. That's GCF, and you're done factoring. So how many answers are we going to have? 2, because it's on the ground twice. I have negative 16t equals 0, and I have t minus 5 equals 0. So this right here means t equals 0. That's an important one. We already knew that one, but that's still important. And t equals 5. That's the one I actually want. That gives me the other side of my interval here. Okay? Because it said from the maximum to when it hits the ground. The maximum, the time is 5/2. And when it hits the ground, it's 5. We good? So we have found those two pieces. Now we got to go find the average rate of change, which means we have to find the function values. So the first thing we're going to find is first thing we're going to do is f of 5/2. That's equal to negative 16 times 5/2 squared plus 80 times 5/2. All right, so this gives me negative 16. What's 5/2 squared? 25 over 4. It's easy to square a fraction. 25 over 4. Square the top, square the bottom. Plus, and anytime I multiply a whole number times a fraction, put that over 1. So I can reduce this, and the 2 and the 80 make that 40 times 5 gives me 200. Or you can multiply 80 times 5 and get 400 and divide it by 2, whatever works for you. And then when I need to multiply this, if I just put this over 1, I can multiply straight across, or I can reduce. 4 goes into 16 4 times, so I really just have 4 times 25. What's that? 100. So negative 100 plus 200 gives me 100 for my f of 5/2. Everybody okay so far? All right, so I'm going to give you a minute. I want you to find, I just realized I put F, and it doesn't really matter but it's really H. Whether you put F or H, it's okay. I'll do H on this one. Let's find H of 0. So find that for me while I go check roll. Yeah, it's not H of 0. That doesn't make any sense. It's H of 5 because we're using these right here. So H of 5 is what I want there. All right, now I'll give you a minute. What is H of 5? Did you have to do any work? Nope, because you'd already found it right there. You know that whole work smarter, not harder? If you understand what you're doing and why, you can save yourself some work. Because when I said find H of 5, I didn't even say substitute it in. I just said find H of 5, right? And so that's what this is. When the time is 5, it's on the ground. We had already done that, right? And H of 0 is 0 also. I guess that's why I had on the rain, I don't know. But it's okay that you did work. Don't go erase it. I'm not saying erase it. Leave it so. Okay, then maybe you want to erase it. But, well, and that's the other thing. When you're substituting in 0, I mean, the thing looks, it's not even that difficult. I'm not trying to make you feel stupid because I know you're not the only one that missed it. But you know, it's not even that hard, but you don't even have to do it because we make silly mistakes and that happens. But that's it. You don't always have to do all the work if the stuff is already done. So, but if you're only doing stuff because you did it on the problem before and so that's why you're doing it, and you have no clue why you're doing it and what these numbers mean, then you can't do that. Then you're not going to be sure that the answer is really 0. But if you understand what you're finding and what it means, then you don't have to do as much stuff. All right, so now we actually have to find the actual secant. So I need to find f, or not f, it's h. Let me use the right letter this time. H of 5 minus h of 5/2 over 5 minus 5/2. So h of 5 is 0 minus h of 5/2 is 100 over, what's 5 minus 5/2? 5/2, right? And so that gives me negative 100 over 5/2, which is the same thing as negative 100 times what? 2/5. And so 5 goes into 5 once, goes into 120 times. So I end up with negative 40. And I got to have units on here. What do you think? It's negative 40 what? Feet, seconds, minutes? Feet per second. We want the average rate of change in the height of the ball when it reaches the maximum height. So your rates are almost always something per something. Miles per hour, feet per second, dollars per unit, right? And it tells you it's feet and seconds, so we at least know our units here. But it's negative 40 feet per second. There you go. And the fact that it's negative makes sense, right? Because it's when the ball's coming back down. All right, is it slowing down? All right, we good? Any questions at all? Not yet. Okay, good.